Okay, now we talk about inverse function relations, alright? First, we talk about how do we find if we have a function, how do we find inverse function of this function, alright? What's called inverse function? The method we use is just two steps. We can make an independent variable, here is x, become a subject first, and then you just go straight swap x with y, alright? For example, we have linear function like y equal to 3x plus 5. Okay. Now method 1, step 1, make x become subject. So x independent variable, we just make x become subject. So we become what? Y minus 5 equal to 3x, right? 3x equal to y minus 5, right? And then divide by 3, right? Divide by 3. We get x equal to y over 3 minus 5 over 3. Right? Now we get what? We get so now step 1 finish. Step 2 swap x with y. So x become y. So x become y. Y equal to y become x. X over 3 minus 5 over 3. So original function, inverse function, we get inverse function is y equal to x over 3 minus 5 over 3. If you write down this one, f of x equal to 3x plus 5, you use this form, so we can denote inverse function become y. Here can write down inverse -1 f of x equal to x over 3 minus 5 over 3. Okay? So you can say this function is inverse function of original function, and at the same time, this function will be inverse function of this one also. Alright? That's inverse, how to convert inverse function and how to find the inverse function. Okay? And then now we talk about the most important characteristic of the inverse function. The graph of a function and its inverse function are reflections of each other across a line y equal to x. So what does it mean? We can try to draw this graph. How do we draw the y equal to 3x plus 5? Fx, y equal to 3x plus 5. So we just when x equal to 0, y is 5, right? When x equal to 1, y is 6. Okay, so we get a graph. x0, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5, 6. We draw another line, we call y equal to x over 3 minus 5 over 3. We use any point. When s equal to 0, y is negative 5 over 3. Okay? Negative 5 over 3 around here. Y equal to 0, x equal to 5. 2, 3, 4, 5. Equal to 7. Right? S equal to 0, y equal to negative 5 over 3, and 1 and 2 over 3. Oh, sorry, here is wrong. No wonder. When s equal to 1, y equal to 8. One, two, three, four, five, zero, 5, 1, 5, 6, 7, 8. That makes sense. Okay. Okay, now we try to draw this line. Y equal to x. Y equal to x 1 1 2 2. Do you find that? It's very beautiful. This one and this one depend on y equal to x and reflect. Right? If you reflect this one, it will become this line. They are reflect. This is y equal to 3x plus 5. And then this one is y equal to x over 3 minus 5 over 3. Right? And the point must reflect because you can check. You have point here, right? 0, 5. If reflect depend on y equal to x, here must be 5, 0. Do you find that? 5, 0, 0, 5. See? So we try. Do we have a1 here? If 1, 8 must be f1. So when x equal to 8, 8 over 3 minus 5 over 3 equal to 3 over 3 equal to 1. See? We have 1, 8 here. You must have 8, 1 here, right? 1, 8 and 8, 1, right? See? Okay. That's called inverse function. And another two very famous inverse function I can introduce now. We copy here and then the second very inverse you must learn before. I teach you before. What's that? Exponential. Remember? Y equal to 2x. 2 power x. Remember when I teach you log, I say what is inverse? It just become what? How do we find inverse? X equal to log. Remember 2 y, and then you swap x and y. We get an inverse must be y equal to log 2 power x. We don't use 2. We use 10. It's fine. Okay. We use base is 10. Still the same. Okay, so y equal to 10 power x and y equal to log 10x. These two functions, they are inverse with each other. So on the graph, how do we draw this? You will find out. If you use the calculated graph, use a Wolfram alpha, y equal to x in here. The y equal to 10 power x must be like this. We pass 0, 1. And the log must be pass 1, 0. That's y equal to 10 power x. And then this is y equal to log 10 x. Alright. They are inverse function. Right? But when we teach here, why always we put relations? There is another example you need to understand. I emphasized before. Another one. Find the inverse. Original function is y equal to x squared. So what happens for this? Here, make x become subject. Right? You just use this one. I told you. When I am doing the find the inverse, you can just do the swap x and the y first. You can do the step 2 first and then do the step 1. The answer will be the same. It doesn't matter. Alright? So here we can become what? X, y squared equal to x. So become x equal to y squared. Do you find out this easy? And then we get a y equal to x squared. No? You will swap, right? Sorry. So in here we always swap x and y, right? And then here you just find a y becomes subject. So you get y equal to positive and negative square root x, right? See, we get which function too? Originally this one. One one zero zero here. And another one must be this y equal to x squared. And its inverse is not a function, its inverse becomes a relation when x equal to 1, y still equal to 1 here. That's what it is. We will all pass 1 1. 1 1 here, right? We will pass 1 1. Yeah. But this one is called x equal to y squared. Okay. But outside, this is a relation, not a function. But this one can separate, become two functions. So upside is called y equals square root x. Downside is called y equals negative square root x. They are the same. Reflect depend on y equal to x. Okay? This is inverse. So this is the original function. This one is inverse relation of this function. This is not function. But this function can, this relation can separate two parts. One part, upside is function, downside is function too. Alright? This two is very famous.